In this video, I will talk about the main requirements of pressure reducing valves in fire protection system by reviewing the NFPA standard 13 version 2022 chapter 16. It mentioned that the PRV shall be installed, as we know, when the system pressure exceeds 12 bar. But you have to consider that the setting point of the PRV shall be less than this number to ensure that the system pressure will not exceed the 12 bar. The setting point of the PRV should be lower than 12 bar by at least 10 psi. This means you have to set the PRV to operate when the pressure reaches to 11.3 bar. This is the first note. The second note, the PRV, the outlet side of the PRV shall be able to withstand the maximum system pressure. In some situations, the system pressure may reach to 20 bar or exceeds 20 bar. So the rating of the outlet side of the PRV shall be able to withstand these high pressures. The third note, to be able to monitor the pressures before and after the PRV, pressure gauges shall be installed on both on the inlet and outlet sides of the pressure reducing valve. As we see here, we can find the pressure gauges installed before, here after the PRV. Here, this is the PRV, pressure regulating valve. This is the pressure gauge after the PRV and pressure gauge before the PRV. This one monitors the pressure before the PRV. In addition, a pressure relief valve with a size not less than 15 millimeter shall be installed either separately after the PRV or built in with the PRV. Some manufacturers provide the PRV with a built-in relief valve to relieve the excess water or the excess pressure to keep the system pressure as the setting point, which is, as I mentioned before, 11.3 bar. Also, isolation valves, usually butterfly valves, shall be installed before and after the PRV. The reason for the pressure or for the isolation valves to enable the operation team to or the maintenance team to implement any maintenance required in the PRV or testing the PRV. Another point, but I think it is not mandatory. NFPA requires to install a test connection, which is usually a landing valve, to check the water demand after the PRV is equal to the system demand. After the PRV, for example, in a zone control valve, the system demand may reach to 300 or 400 GPM, for example. So the test connection after the PRV should be installed to ensure that system demand is equal to this number. Uh, no test connection in this image. As I said, it is not mandatory. For the zone control valve, we can use the test connection is a test and drain line with a side glass. Inspector's test valve may be used to, as I mentioned, to check if the water demand after the PRV is equal to the required or the designed system demand. In this image, this is a pressure regulating valve, pilot operated, with a built-in pressure relief. When the system demand or the system pressure exceeds 11.3 bar, the relief valve will open to relieve the excess pressure. In selecting the pressure regulating valve from manufacturer's catalogs, we have to check 3 points or 2 points. First, the first point is the system demand or the flow rate. If the flow rate of the system exceeds the system demand or the required flow rate of the system, the system demand as a GPM, gallons per minute, exceeds the listed rating or capacity of the manufacturer's recommendation. For example, if the manufacturers tell that the maximum capacity of the PRV is 100 GPM and it will be installed on a system with a 200 GPM. In this case, we have to use two pressure regulating valves installed in parallel. One will handle only 100 GPM and the other one will handle 100 GPM. So they shall be installed, in this case, they shall be installed in parallel. This is the first point. The second point is the pressure reduction or pressure ratio before the PRV and after the PRV. And this is an important factor. In some cases, the downsize or the pressure ratio before the downsize in pressure from high pressure side to low pressure side exceeds 10 to 1. For example, we can see here 20 or higher bar, and it's only required to provide 4.5 bars downstream of the pressure regulating valve. In this case, we have to check the graph of the manufacturer, like this one. The vertical axis shows the inlet pressure and the outlet pressure on the horizontal axis. For this equation, it calculates a dimensionless number, K. If K, it's a function in outlet pressure and inlet pressure. If outlet pressure or if the dimensionless number according to this equation less than 0.5, cavitation will occur in the pressure regulating valve, and this phenomenon is not recommended. It will damage the piping and the PRV. Uh, so you have to keep this number higher than half. 0.6 to 1 is recommended. Okay, if the case, we cannot mandate this dimensionless number below 0.5. What is the solution? The solution is to use two pressure regulating valves installed in series. Pressure reducing valve station followed by another one. Each pressure reducing valve station have a pressure ratio. For example, if the pressure here is 20 bars, the first one will reduce the 20 to 15, and the second one will reduce from 15 to 10 bars. So we have to keep this point in mind, as it's very important in selecting the PRV. Here, this is the configuration of the pressure regulating valve station. Pressure regulating valve should be installed after a strainer to avoid the accumulation of debris and impurities in the PRV. Also, as I mentioned, isolation valves, butterfly valves before and after, pressure gauges, and bypass line recommended to be installed if the system pressure from the external network, water supply network, will not reach to a higher values. So there is no need to use a pressure regulating valve, and the bypass line will bypass the PRV, and the pressure provided with the network will be used in this case. So this is the main features that shall be achieved in selecting the pressure regulating valve. Thank you.